Hello, my name is Vincent Cupertino, and I'll be presenting on the attitude indicator, specifically in the Piper Seminole. Today we'll discuss the following topics. We'll do a brief review of the analog attitude indicator, a review of the digital attitude indicator, where to find the attitude indicator in the Piper Seminole, how the digital attitude indicator receives data, and errors related to the digital attitude indicator as well, and then finally, how to interpret the attitude indicator. So let's get started. The analog attitude indicator is a gyroscopic instrument, gyroscopic device that uses precession and rigidity to provide information to the pilot. To review these principles, the precession effect is when an outside force tries to tilt a spinning gyro. The gyro responds as if the force has been applied at a location 90 degrees farther around in the direction of that rotation. Rigidity in space is the principle that a spinning object tends to remain spinning with its axis pointed in the same direction. Now that we've reviewed those principles of a gyro, let's discuss the gyro specifically within the attitude indicator. The gyroscopic wheel, the gyro, spins in a horizontal plane that is parallel to the horizon. That gyro is mounted on a set of gimbals that allow it to remain rigid in space with its axis of rotation pointed in a constant direction. Gimbals are the spinning metal wheels mounted in brackets, just so you know. One gimbal is directly attached to the bank reference to show accurate banking information on the attitude indicator. To show the pitch changes accurately, the motion of the gyro relative to the case must be reversed in order to move the horizon bar correctly on the instrument face. Using that mechanical linkage performs this task. So you can see on the slide, the reversing linkage allows us to see the pitch changes accurately. Now, errors in the analog attitude indicator include instrument tumbling. So if you exceed a pitch or bank limit, the gyro gimbals will reach the limit and they will precess rapidly, and the instrument will be unusable for several minutes. The pitch limit is about 60 to 70 degrees, while the roll limit would be about 100 to 110 degrees of roll. Also in the analog attitude indicator, there are pitch and bank errors, and pitch and bank errors are minor, resulting in less than 5 degrees of bank error, less than 1 bar width of pitch error. The large pitch and bank errors will occur after the aircraft rolls out of a 180 degree turn. Rolling out of a steep 180 degree turn, the attitude indicator will show a turn in the opposite direction and might show a slight climb as well. A skidding turn can create even more precession. So when you return to straight and level coordinated flight from a skidding turn, the attitude indicator shows turn in the direction opposite of the skid. Okay. Some things to review during your pre-flight, your run-up, and or your before takeoff checklist are the following. You can check for operational warning flags. Those will show up on the attitude indicator. This is for any unusual noises during the start of the engine. Give the gyro in the attitude indicator 5 minutes to spin up. Make sure the horizon bar tilts no more than 5 degrees during taxi turns, and check the suction gauge in the before takeoff checklist. So all things that you want to review to ensure that your attitude indicator, your analog attitude indicator, is working correctly. Now that we want a brief overview of the attitude indicator, let's dive into the digital attitude indicator. Now, first, we're going to talk about the data in the digital attitude indicator. Where does that come from to see what we see on the primary flight display? So first things first, the attitude indicator is located on the primary flight display within the Piper Seminole. On the primary flight display is the GRS-77 Attitude Heading Reference System, abbreviated as AHRS. The AHRS system uses internal inertial sensors, GPS information, magnetic field data, and air data to assist in attitude heading calculations. So if you look at the slide here, I mentioned those, mentioned AHRS, magnetometer, GPS, and air data sensors all go to our primary flight display, shown partially here. Okay, so let's dive in a little bit further. Inertial sensors, such as electronic gyroscopes and accelerometers, determine the aircraft's attitude relative to the horizon and the direction which is moving. The GPS receiver helps provide attitude data as well, especially in the Piper Seminole. An electronic magnetometer provides magnetic heading data, which is also helpful with the attitude indicator. And then finally, air data sensors, such as the pitot tube, can provide information for the attitude indicator as well. So now that you know a little bit about what is used to collect data for the attitude indicator, let's dive into some potential failures of the AHAR system. All right. So if either the GPS or magnetometer are unavailable or invalid, the AHARS will use air data information for attitude determination. If it's a loss of air data, GPS or magnetometer sensor inputs, that will be a message advisory alert that will be communicated to the pilot on the AHARS system. Any failure of the internal AHARS and their inertial sensors result in loss of attitude and heading information. That's when you'll get the red X over those corresponding flight instruments. If both GPS inputs fail, the AHARS can continue to provide attitude and heading information to the primary flight display, as long as the magnetometer and airspeed data are available and valid. Any invalid, unavailable airspeed data in addition to GPS failure results in loss of all attitude information. And then finally, if the entire AHARS unit fails, again, a red X will be displayed over that attitude indicator. It's important to note that AHARS could reset in flight, and they will try to realign itself while the airplane is in motion. And alignment can occur quicker if the wings are kept level during the alignment process. Something to note. All right. So now that you know about the attitude indicator, how it receives data, and what errors can occur on the actual digital attitude indicator, let's discuss how to interpret the digital attitude indicator and attitude indicators in general. All right. So the attitude indicator provides immediate and direct information, an indication of the airplane's pitch and bank attitudes, and it's extremely important when in unusual attitudes. If, as a pilot, you are in unusual attitudes, please remember brown power down and blue power through. It's something that I learned during my flight training that helps me interpret unusual attitudes. As a pilot to use the attitude indicator, you will use the aircraft symbol, which is number 4 here. Let's say, for example, you are in a right turn. You would see the left wing in the blue represented as the sky, and the right wing in the brown represented as the ground. If you are pitching up, you'd see that aircraft symbol in the blue in the sky. If you're in a pitch down attitude, you would see that aircraft in the brown. Once again, the first thing you should do if you're in an unusual attitude, look at your attitude indicator and remember brown power down and blue power through. That will help you get out of that unusual attitude at a quicker speed. All right. Differences between a digital attitude indicator and the analog attitude indicator. There's no knob to adjust the indicator for a digital attitude indicator since there are no mechanical instruments. And there's also a slip skid indicator that's shown on the digital indicator, and those are the main 2 differences. Okay, so let's dive in just to some of these different symbols here on the attitude indicator itself. The digital attitude indicator information is displayed over a virtual blue sky and brown ground with a white horizon line. And the attitude indicator will display that pitch, roll, and slip skid information that I briefly touched on. So we'll review each number quickly on the slide. Number 1 is the roll pointer. The roll pointer will move with the airplane during a roll and will indicate the angle of bank on the roll scale. Number 2 is the roll scale. It has major tick marks at 30 and at 60 degrees, and minor tick marks at 10, 20, and 45 degrees. The horizon line is a part of the pitch scale and helps to indicate the attitude of the aircraft. Number 4, as I mentioned previously, is the aircraft symbol. All right. Number 5 is brown, and that is representative of the ground. Number 6 is the pitch scale. The pitch scale will show major pitch marks every 10 degrees up to 80 degrees. um, of pitch. Minor pitch marks show 5 degrees up to 25 degrees below and 45 degrees above the horizon line. Between 20 degrees below to 20 degrees above the horizon line, the minor pitch marks will occur every 2.5 degrees. The slip indicator is number 7, and that's the bar beneath the roll pointer. That indicator bar moves with the roll pointer and moves laterally away from the pointer to indicate uncoordinated flight. So a slip inside the turn or a skid outside the turn is where that bar will be relative to the pointer. 8, I mentioned before, the sky is the blue. Then 9 is the roll scale 0. So when the roll scale and roll scale 0 are aligned, the aircraft is not in a rolling attitude. All right, I know that went by pretty quickly, but today we discussed the attitude indicator in a Piper Seminole. Information for this presentation was provided from the Piper Seminole POH, the Garmin G1000 Pilot's Guide, and Jeppesen Online Instrument Course. So once again today, we talked about a brief review of the analog attitude indicator, a review of the digital attitude indicator, where to find the attitude indicator in the Piper Seminole, how the digital attitude indicator receives data, how to interpret the attitude indicator, and some errors as well related to the digital attitude indicator. Thank you for your time.